Okay, next video here. So we've started talking about this thing called the derivative at a point. And so we drew the pretty picture that's up there where we saw the secant lines approach the tangent line, and then that gave us a limit. That limit would give us the slope of the tangent line, and then we gave it a special name, the derivative. The derivative at the point x naught is f prime of x naught equals the limit as h goes to 0 of f of x naught plus h minus f of x naught all over h. We are now going to practice finding this limit. So some generic steps here on how to find that limit. 1, substitute in the value for x naught. You're always going to be given a specific value for x naught. 2, find f of x naught plus h and f of x naught. 3, simplify the numerator as necessary. A, if f of x is a polynomial, try multiplying out and combining like terms. B, if f of x is a fraction, try moving the over h off to the side as times 1 over h, then combine the remaining fractions using a common denominator into a single fraction and simplify. C, if f of x is a radical, try rationalizing and simplifying. 4, if you've done your work correctly, all the terms should contain an h, cancel the h. And then 5, evaluate the limit, substitute h equals 0. Okay, let's start doing a couple of these. Again, there are shortcuts. There is an easier way to do this problem that would take, 30 seconds to do. When we get to those shortcuts, you can use them, but until we get to them, we cannot do them. Find the slope of the function's graph at the given point, then find an equation of the tangent line to the graph there, graph both the function and the tangent line. I think I have a tendency to think that my pages are a little out of order here, so we'll have a little algebra. Well, no, never mind. They're not out of order. Forget it. Forget everything I just said there. So we'll start with the first part. Find the slope of the function's graph at the given point. Okay, so the slope. Yeah, let's spell it right, shall we? Slope of y equal, and I'm going to rename it f of x equal to 4 over 2x minus 3 at x equals 3. Is given by f prime of 3. So m equals f prime of 3. The derivative at 3. And so we're going to use the f prime of x naught is the limit as h goes to 0 of f of x naught plus h minus f of x naught all over h, with, in this case, x naught equaling 3. And so we just want to work out this limit. So, first thing I'm going to do, and I've got my steps up there, so we'll label this guy step 1. And I'm going to replace that x naught with a 3. 3 plus h minus f of 3 all over h. So there's step 1. Step 2, we're going to apply that f of x is 4 over 2x minus 3. So f prime of 3 is going to be the limit as h goes to 0. Now, f of 3 plus h, and one of the most common mistakes people make are right here, what that symbol means. F of 3 plus h means take your formula for f, whatever it is, in this case 4 over 2x minus 3, take your formula for f, replace the x with whatever's in parentheses. So this is going to be, and I'm going to need a little more room here, f prime of 3 is going to be the limit as h goes to 0 of 4 over 2 times 3 plus h minus 3 minus 4 over 2 times 3 minus 3. So what we have here, there is f of 3 plus h. There's f of 3. That I just replaced the x in the first case with 3 plus h, and in the second case with just 3. And now we're going to simplify. And if I go back to my steps over here, so we're up to step 3 here. B, if f of x is a fraction, try moving off the over h to the side as times 1 over h. So we want to simplify here. So step 3, simplify. And what we want to note here is this means divided by h. When something's in the fractions are division, and all that means, a fraction means division, and it just means you're dividing by the denominator. Well, divided by h, using horrible notation, would be divided by h over 1, which equals times 1 over h. Horrible, horrible, horrible notation. But divided by h is putting an h, putting a 1 in there would be h over 1, and then you remember from, like elementary school that dividing a fraction means multiplying by the reciprocal, or what my children learned was, they learned to keep it, change it, flip it, which means changing, you keep the first function, you change the division sign to multiplication, and then you flip it. Keep it, change it, flip it, they learned. I prefer the more precise thing, multiply by the reciprocal. So what we get here is that this is the limit as h goes to 0 of 4 over 2 times 3h minus 3 minus 4 over 2 times 3 minus 3. And we'll simplify all that in a minute. Times 1 over h. That's the easiest way to handle that all over h. Move it off to the side as times 1 over h. That instead of dividing by h, we're multiplying by the reciprocal. Now we just keep simplifying. And so I'm going to just do some basic simplification here. That's 6 plus 2h minus 3 minus 4 thirds times 1 over h. Keep simplifying. The limit as h goes to 0 of 4 over 2h plus 3 minus 4 thirds times 1 over h. At this point, what I want to do here is I want to combine these into one fraction with the common denominator, which we will always in this class be CD, of 3 times 2h plus 3. That's the trick here. So there's kind of two tricks when I'm dealing with fractions. First, what to do with the divided by h, so that I move it off to the side as times 1 over h. Then, with the fractions themselves, combine into a single fraction by getting a common denominator. So, showing every step here, getting a common denominator. That first fraction has the 2h plus 3. It's missing the times 3, so numerator and denominator times 3. The second fraction has the required 3, but it doesn't require the 2h plus, it does not have the 2h plus 3, so numerator and denominator 2h plus 3. Keep simplifying. And I am showing almost every single detail I could do. I'll leave that minus sign for later, so I'm just taking that 4 here and distributing that 4 for 8h plus 12 over 3 times 2h plus 3. I now have a common denominator, so I can combine those fractions. Remembering now that I'm going to distribute that minus sign, And when I distribute that minus sign, those 12s are going to cancel. And so I get the limit as h goes to 0 of negative 8h over 3 times 2h plus 3 times 1 over h. And notice now that I have done all my simplification up to this point, I can now legally cancel my h's. That's what you are always building to in each one of these definition of the derivative problems, that you're trying to legally cancel your h's. And that is what we will do on the next video.